Okay, I'm set up and ready to start turning the stainless impeller down. We're taking it down to 5.5 inches. So we're going to be running this is a CNMG insert right here. I don't remember the grade of this. This is one I've had in my cabin a while. I know it's a Mitsubishi. So we're just going to see how it does. I'm just hoping that I end up with one that doesn't try to chip on me with this interrupted cut, but we've got plenty of different inserts we can try if we need to, okay? I'm gonna be running some flood coolant on it as well, keep everything cool. So we'll start off with, let's just try 200 thousandths a pass and see how that does. Get some coolant coming. It would help if I turned the pump on. That's probably why it's not coming out. There we go. Just going to have it dripping down here from the top. Setting up the feed rate. I'm going to put it on 10 thousandths. Put my earplugs in because this sucker's going to try to ring on me. See how it does. Wrong feed direction. I think I've already got that tool. I can tell. Yeah, it chipped the end off right away. It started pulling it up in there. All right, so that one's not going to work. Let me go ahead and find a different one we can use. Yeah, I'm going to go back to my trusty ISCAR insert. This is the one you generally see me use all the time. It's the IC 8250 is the grade, TF chip breaker, 431. So let's give this a shot and see if it'll hold up. Let's try it again. See what happens here. Hey, got the job done. That's a little bit of an aggressive cut on the interrupted cut like that, but it seems to be working. Got that one too. Dang. Just tries to pull it up in there further and further. That one, it kicked the tool around. All right, try it again. That last one might have been a little bit my fault. I generally don't tighten these very much for a lot of the work that I'm doing around here, and I probably didn't have these very tight. I don't know if that was the case, but probably a combination of wrong insert, too high of a feed rate with that interruption cut, and then the tool not being tight enough, kicking around, digging in even tougher. So I got it backed off to 150. Let's try it again. I'm going to slow the feed rate down. 8,000 feed rate right there instead of 10. slinging coolant up on my mic there. I got to move it. All right, that time it worked a little better. We got through it, so that might be it. Just backing off on our cut a little bit, slowing the feed rate down so that it's not hitting so hard. You got to have the proper grade for a little bit more impact resistant when you're doing this interrupted cut like that. Do a quick check here and see where we're at on our size. We should have plenty. Yeah, we still got well over an inch to take off this thing. Another 150 pass right here. Try it again. Try to back off on this coolant so it's not slinging so much. Acts like it's got that tool again. Beating and banging pretty hard. Yeah, it's got the corner of it. Once again. Yeah. Man, it seems like it gets right there every time and then tears the tool up. I think we might go to a different style of insert. I might grab my Element X and see if it has a little bit better heavy duty turning capabilities. All right, I think we're going to give this guy a try right here. This is a SLANR tool. It takes an LNMX insert. These are made for heavy stock removal right here, deep cuts and coarse feed. But we'll see how if it'll hold up to the stainless steel. All right, I decided to go ahead and add a center to the mandrel there. We'll use a live center in there. That'll help create a little bit extra rigidity for the whole setup. Okay, another attempt. See how this one does, if it chips it off too. 150 thousandths. Yep. Sounds like it's doing the same thing. Man, I can't catch a break today. I knew this was going to be a little problematic, but I didn't expect it to continue to do this right here. It definitely got it. It got the corner of the insert there. So I just keep selecting the wrong grade of insert. So I got to keep going until we find the right tool. Okay, next one I'm going to try right here. This is a DNMG style of insert right here. But the reason why I want to try this, I recall this was an Ingersoll insert. VF was part of it, stands for vibration free. It's a positive style chip breaker molded into that insert there. And I had used this on a big job at Motion. I had this big stainless steel tube in the lathe. It was a Weldman. It had some pieces welded on it, and I had to turn that thing down, and I was using this tool right here, and I recall taking like 400,000 to pass in stainless. So let's see if it works over here on this little job compared to what I used it on. But I've just got a lot of things working against me right here. This interrupted cut, beating and banging, and you know, I guess I need to go ahead and figure out the proper surface speed I may be running a little bit too fast too. Okay, I might have found a combination that's working better for me. This is my MCHNN tool. It uses a CNMG insert, but you can see how it's seated on the tool right there. So we've got a really steep lead-in angle to it. And in the insert itself, this is a Seco TP3500 grade of insert. I've made 3 passes on it and it's worked out. I backed off to 100 thousandths metal removal, and then we slowed it down to 100 RPM. So let's see if it'll continue to make a cut. I'm trying to keep the tip of the tool flooded underneath the coolant. Okay, good, another successful pass. So since this combination is working for me, I'm just gonna keep doing this till we get it down to 5.5. I'm down to my final 2 cuts there. We got 50 thousandths to bring this thing down to 5.5. What I've been doing is feeding from left to right just to try to help cut some of these heavy burrs off there on that inside. We already know we're going to have to get in there and deburr that with the grinder, but I was just trying to eliminate some of that stuff that's been rolled over there. So we'll go ahead and start our next cut here. That's just a 25 thousandths pass. Seems to be working fine. And we'll have one more cut after this. All right, that's saying I got 30 thousandths. 30 thousandths to bring it down. $30 thousandths. Finish cut. All right, we've got her down to our 5.5 diameter. Got a good finish on it. I'm just going to go ahead and break the 2 outside corners using the tool we got in there. So this thing's got some pretty nasty burrs on it from the turn-in, but this is all we're doing. We're gonna use the pliers here to remove the bulk of this right here, just like that. And we'll keep peeling some more of the this off of here, about like so, and then get the air grinder over here with a carbide burr, and just come in here with the burr and remove the big stainless burr off this impeller. Trying not to mar up the surface if I can help it, the machine surface. Go through here with the carbide burr. We got a 90-degree angle or a right angle grinder and then a straight grinder right there. And once we get the heavy bulk removed, probably go in there with this cartridge roll and just kind of blend and soften up that edge a little bit. All right, earplugs, eye covers, eye shield, and some gloves here. think we're finally finished up with that. This edge here still had a little bit of burr right through here, so we got that polished off good. So I think we are about done with this whole thing. Just giving this ring a nice little polish to finish it out. Not really necessary, but I like to make it kind of, I don't know, pretty it up a little bit. Just using some 220 grit. Not really applying a lot of pressure. Just wanting to polish up, and I want to soften that edge up there too. And take this one and go around the OD. Let's see, I think I got some Scotch-Brite around here somewhere. Just giving this thing a nice little wash down, then the CRC Smart Washer here. Get rid of the oil and coolant that's still on it, and then wash off any of the fine burrs and chips that's still stuck on there. Okay, well, our impeller is all finished up there. I'm real happy with the way everything turned out on it. All of our finishing, our sizes, dimensions came out really good. We've got our OD turned down to 5.5. All of the burrs have been removed. All the edges softened up, so there's no sharp edges to cut your fingers on. It's always really important. Remember, do all your deburring before you hand the part away to someone else, especially the customer. Never leave a sharp edge on there. The seal ring turned out real nice. I was disappointed with how badly out of round it was, especially after the welding on there. But our Eutectic flame spray equipment did a good job on the metallizing and building up, and I have 100% confidence this is a good repair for a part like this, especially when talking to Eutectic Direct and them telling me about their history of doing parts like this, in industry and having good results with it there as well. So I have complete confidence that it is a solid repair. So this guy's finished up. Now, one of the comments that comes up in discussion quite a bit, especially when I was showing some teaser shots on Instagram, is people asking about it being balanced. And in fact, it does need to be balanced. This is an important part of a part like this that's rotating. I'm not going to do the balancing myself. The customer is going to handle having it balanced. So, you know, give this somebody like an electric motor shop or a pump shop that has a balancing machine so that they can properly balance this thing. They'll have to come in here. That's what you see right here. There was a little bit of grinding on it right there. There's a little bit of grinding on it on the inside right there where they're trying to remove a little bit of the weight to get it properly balanced. So this will have to be done as well. I've already got more time in this than what I originally thought I was going to do. I don't do balancing here myself, so the customer is going to handle that on their end. Okay, so that's it. This guy is finally finished up. We're going to go ahead and get it boxed up and get it sent back to him. I hope you enjoyed this repair and these couple of videos, and we'll see you on the next job. Okay, later.